In this chapter, we will discuss transaction processing within single and multi-user database management systems. No, these are not the TPS reports discussed in the movie Office Space, though the many people are confused by them. A transaction here is not the same as you have seen previously associated with currency. Here, we define our key terms for this chapter in transaction or transaction processing systems. We have previously discussed how a multi-use database management system allows for concurrent access for many different people. This is confusing, as the second statement actually suggests the processes are being done one at a time and not concurrently. Generally, what happens here is the processes which require the least amount of bits or bytes go first. Here we have an example of interleaved processing, which is done concurrently, and parallel processing, which is like multi-programming, where the quicker task goes first, then the next process. You can have different types of transactions based on the process you need to execute. We have previously seen the parts of a database and data items. Granularity, you may remember from your programming courses, tries to rid us of redundancy. We can read or write to our database using transaction processing commands. Here, we have examples of using read and write commands. In A, we have 2 read and writes. In B, we only have 1 read and write. Buffers, no, not Michael or Bruce, can be used as a go-between waiting area. One process is going on while another waits. Ideally, in a company, you do not want to assign the same exact task to multiple users to avoid the lost update problem. Look at it this way. If 2 people are updating the same thing at the same time, whoever updated last will see their result. It overrides or overwrites the first update. Think of your programming. If you were to assign the variable name Betty and then assign the variable name Mark and ask to print out the variable name, it will print out Mark, whatever the current state of the variable is. Notice the difference in code, which is symbolizing user T2's command update will only be seen for a short time before user T1's command finishes and overwrites it. With the incorrect update, both users end up with incorrect updates to the database they were updating. Half of each command is going on at once. An unrepeatable read problem means an update occurred between read commands, generally a write command, which resulted in different reads for the same attribute. Think of using Access Excel, Word, or PowerPoint. When it crashes and you reopen, you may be asked to recover a file. Same applies here. We don't want a damaged or corrupt file. As with previous topics discussed, we have commands associated with transactions. Think of the rollback command as the undo button. Here we have an illustration of the order of these commands, what they impact, and potential outcomes. Transactions are kept in a system log. similar to actions of a virus detection software on your computer. In theory, you have not really done anything until you commit to your transaction. Then things officially change. There are certain policies you can use to avoid needing to use a buffer. Remember back to CAP theorem? Transactions have ACID properties. These properties allow users to have smoothless transactions. Isolation is broken down into different levels. Ideally, we don't want multiple users reading and writing in the same database at the same time, so we set capabilities. There are various schedules you may adopt to ensure isolation occurs. Serializability tells us the transactions are going through in the order in which they were submitted. Here we see a visual representation of serial and non-serial schedules. There are some issues related to serial schedules. Primarily, users are always waiting for their results. Your results are based on the order of the processes. If conflict exists, use serializable schedules. They must be addressed. Here are some steps we can take to try and determine if conflicts exist and avoid them. Here is a visual example of serializability. Serializability can be thought of like a four-way stop. No one knows who goes. Creating visuals of schedules as seen can help determine which transaction process strategy to use. As we have seen, we may need constraints to address issues or create assumptions. We can use transactions in SQL using similar commands, but no begin command. Here is a visual describing potential violations based on our isolation levels. Dirty read gives us wrong info. Non-repeatable read, as seen, gives us two different read results. Phantoms are missing data that ideally should be there. Snapshot is based on the exact date at that time, or data at that time. Think of a picture. You take a picture and you see what happened at that time, not 6 hours from now. You should now have a stronger grasp on transactional processing in databases.